So hello everyone, today in this video we'll be solving a GFG problem, that is sitting arrangement. So let's first read the problem. Given an integer k representing the number of people to be seated and an array seats where 0 denotes an empty seats and 1 denotes an occupied seat. Determine whether it is possible to seat all k people such that no two occupied seats are adjacent, including newly seated people, right? So what basically question says that, here we are given like we have a numbers of seats, right? And out of some means some seats are like occupied and some seats are empty, right? So like they are saying that you need to design your approach, you need to like think about a solutions such that in which no two no two adjacent seats are like occupied, right? So now we'll understand that how can we means solve this problem. So basically first let's look at a constraints. So constraint says that total we can have 10 raised to 5 peoples, right? Which are unseated currently, means this is a k is like number of peoples which are right now unseated and we want to make them to be seated in this particular empty seats, right? And this seat size are like 10 raised to 5, right? So now by looking at constraints we are sure that we need to design a solution that works in either like big of n or log n log n time complexity, right? So you could never think about a solution that works like in n square, otherwise it would lead to TLE, right? So now we have a like pretty much good look at a constraint. So now what we will do, I'll take you my to the news. Okay. So here you can see that if I have taken the first example only here to explain. So our goal is to find is it possible to seat all k people such that no two seats are occupied, right? So what I'll do over here is I'll first like pick first current position, right? So here initially first position is 0 and number of peoples are like the number of people which are unseated is currently 2, right? So what I'll do here, I'll see current position is like 0. So if current seats is empty and its immediate neighboring seats are 2 empty, then allow a person to sit. What does it mean? If this is empty and its neighboring is also empty, so I can say that I can allow a one person from this out of 2 people to sit here, right? So what I'll do, I'll simply put over here 1, means it indicates that this place is now no longer empty, right? So I'll put here 1 and I'll simply just decrement the k by 1. So now only one person is left to be seated. So now what I'll do, I'll again move to the next index and I'll see that this element is 0, means this place is like now empty, but its immediate places are like not empty, right? Means they are occupied, right? So even if single place is occupied, you won't allow any person from this group of k people to sit here, right? If any of the neighbor is like occupied, right? Means any of the neighboring seats are occupied. If so, yeah, I'll not allow him to sit here, right? This is now 1, so obviously we'll not going to allow. Now again I'm here, but it's like before is 1, so again I'll not allow. Now I'm over here, right? At this particular point, at this seat, what I can see that its neighboring are like empty and this is also 0. So I can allow a person to sit at this position, right? Because the neighboring are like empty seats. So what I'll do, I'll simply mark this as a occupied and then I'll also decrement this particular, right? So now no peoples are left, right? And you can see that the entire array is like okay, means we have make such a arrangement such that no two places no two adjacent places are like occupied, right? So answer of this like question is true. Answer of this question would be what? True. I hope you understood this question. So what we are basically doing over here is, now we will look at a second example, right? So in the second example you can see that seats are like 0 1 0 and number of people to be seated is 1, right? So what I can do over here is, now you pick any seat. So what I will do, we will start from the first index, right? So at the first index it is 0 but its neighboring is 1, so you won't allow that person to sit here, right? At the 0th index. Again you can see no, means there is no way. Again here there is no way. So after traversing all the index, right, you know, you get to know that there are no places where in you can sit, where you can allow the people to sit, right? So answer is like false. Similarly over here also answer is false. See here why answer is false, even there is no person to sit, right? So because there are already two seats which are adjacent to each other and are already occupied, so you like obviously like directly send the answer, means return the answer false, right? So now let's have a look at the code. Over here initially I have initialized the n. Then this particular for loop is like making sure that if two adjacent seats are like occupied, then it will simply return the false, right? Because we don't want any two seat to be occupied, right? So we will simply return the false if it is like detected over here, right? Then this for loop like we are using this for loop to like find the main thing, right? That we were understanding in the logic, right? So over here what I'll do, if the seat is already occupied, then no need to like think of to put any person, means to place any person on that particular seat. So I'll simply continue. And over here what I'll do, I'm handling the extreme cases separately, right? So if I is equal to 0, so there would only be one neighbor, that is I plus 1. And if I is equal to minus, means last position, so there would only one neighbor which is like previous to it. So what I'll do, if like next neighbor is like non-empty, means next neighbor is like, okay sorry, next neighbor is empty, right? So what I can do, I can simply mark the current place as a 1, means occupied, and I'll simply decrement the value of k. Similarly I will like check for the last position, that if last position is like empty and its previous position is also empty, right, means I minus 1, then I'll also again do this, set the value to be marked as a 1 and simply like decrement the value of k. Otherwise what I'll do, I'll see the extreme like its neighboring immediate neighbor. If immediate neighbors are like empty, then I'll allow the person to sit over here also and simply I'll decrement the k. And finally if I found that k is 0, means like all the persons are like seated means perfectly, means there is no like two adjacent people, means there are no adjacent like people who are sitting next to each other, right? So if it is that was the case, then what I'll do, I'll simply, means this condition will like take care of it. If the k is not 0, means it will return false, otherwise it will return true. So I hope you understood this particular problem solution, and I would also like to explain this particular line of code, right? So I have like included this, means these conditions, because if you like have only one element, means if you have only the, I can say simple one, means seat available, right? So for that case I have like put these conditions. So if there is only one seat and which is also like free, so you would allow the person to sit over that place, right? So yeah, that's how we can solve the problem. Thank you.